You're running a coffee shop. As customers order drinks, your supply of coffee beans keeps dropping, and if you run out, you can't serve anything. But if you order too early or too much, you're tying up cash and storage space. When should you reorder? And how much inventory is enough without being too much? There's a model for that. Welcome to Model Monday, a series where we break down scenarios in different industries, organizations, and departments, and explain how you can build a simulation of them in Process Playground. Let's model it. Let's start by taking a look at our items. In this model, we are going to show bags of coffee beans getting used up over the course of about 2 weeks. So we're going to call the initial item beans. This model is going to feature our replenishment pull block. So our demand block is going to act in a unique way, called pull mode. In this mode, the demand block does not generate items that enter into the process. Instead, it generates a request or demand for an item. To activate a demand block in pull mode, you'll have it at the end of your process, usually the far right. Now let's take a look at our demand block settings. We'll see here that we have the beans item already in here, and we'll need to set the demand for beans. In this case, we're going to set it to an exponential distribution with a mean of 4 hours. That means on average, there will be about 4 hours between when we need a new bag of beans, and that results in consuming about 6 bags of beans a day. With the demand set up, now let's set up a pull system. First, we're going to bring out this pull block. And when we double click on the block and open the parameters, we'll go down to this section and we'll add an item to the block, and that will be our beans item. The pull block has a lot of different parameters, but the most important ones are right here at the top. It allows us to set the initial amount of items on hand in our inventory, the max number of items we'll have in our system, and the trigger point, or when we'll start to order new items. We'll start with 20 bags of beans in our inventory. Then, for the max items in our system, we'll have 24. Finally, we decided that when we get down to 12 bags of beans, we want to order more. Sizing the system isn't just about setting parameters. It's about deciding how much uncertainty you're willing to carry. Too little and you stock out, too much and you create waste. When we want to trigger an order, we'll need a place that's going to receive that order. Let's close up the pull block for now and create a block in order to catch our order. This Q block is going to be the recipient of our order. So when we go back to our pull block, we can see here that we can set the target queue to Q. This means when we trigger our order, we will create a batch of our trigger item, the beans, in the target queue. After we order our beans, they don't show up instantaneously. In this case, we have to account for shipping. So we'll use an activity block to simulate that time for delivery, and we'll call it vendor shipping. Now let's set some time in here. In this case, we're using a pull block, which creates a batch, which is a group of the same item. In the activity, we want the time to be applied once to the entire batch and not to each individual item within that batch. So in this case, we want to use setup time distribution. This setting, used particularly for batched items, applies time to the single batch rather than each item individually. So we're going to set this to a triangular distribution with a minimum of 16 hours for delivery, but usually within 24 hours, and if there are some delays, it might be 48 hours before we get our delivery. Then we want to set our processing time distribution to a constant of 0, because we don't want any additional time applied to each item in the batch. When thinking about delivery, the longer the lead time, the more inventory you need to protect flow. Now let's connect them all together using the blue circles to make the connections. Let's run the model. We'll set this for 200 hours, which is approximately 2 weeks of open time for our coffee shop. This simplifies from having to open and close the shop throughout the simulation. First, you'll see that when demand is requested, one of the items moves into the demand block. Then you'll see that the pull block starts to decrease. When pull reaches 12, you'll see an item appear in vendor shipping. This is because the batched item of beans moves immediately from the queue into vendor shipping when it's available. Then you'll see the pull block pop up when the delivery has arrived. The batch of beans turns back into individual items when it reaches the pull block, restocking the inventory to be pulled by our demand. Now let's take a look at the results. We can see we started off with 20, and then when we got to 12, that would be the time that we triggered an order at right about 40 hours into the simulation. But we kept consuming our inventory until we got down to 5. Then our inventory arrived, we jumped up to 17, and we began consuming again. When sizing your system appropriately, you want to make sure that you have no stockouts. While you're experimenting, if you see stockouts, you can try bumping up either the trigger point, the max items, or your starting stock. Now, let's take a look at our queue. We can see every time that we received an order. We have an order, then another order, then another order. You can see that the queue considered it one order even though they are a batch of several bean items. Once we look in our activity block, we can see how long our activities took. It took about 30 hours to receive our first shipment, the second took almost 40 hours, and the last one was a little under 20. Finally, we may have some interest in how our demand looked over the course of the simulation. So we can take a look at the queue length in our demand block. You can see how it is steadily increasing as we use up our beans items. So in a nutshell, that's the coffee bean restocking model. But the real value is in what you can experiment with. By modeling how inventory is used and replenished, you can see how your reorder point and order size affect whether you run out or carry too much. The goal isn't to get the right setting. It's to understand how demand, lead time, and variability interact. And it's not just coffee beans. The same pattern shows up in raw materials in manufacturing, medical supplies in a hospital, spare parts for maintenance, or products in a retail store. Anywhere, you need to balance availability with excess inventory. From here, you can start to ask real design questions. When should I reorder? How much should I order each time? What happens if demand increases or becomes unpredictable? Or if deliveries take longer than expected? You don't want to run out, but you also don't want a closet full. There's tension between availability and excess. That is the kind of trade-off this model is built to explore. That's the model. Now go experiment. Happy modeling!